Let us do a quick recap of what has been discussed until now. We have started off discussing about the data types, and we discussed about random variable. We discussed about how to calculate probability distribution, and sampling funnel. Post which we have discussed about first moment business decision. Another name given to this first moment business decision is measures of central tendency. As part of this, there are three key measures: mean, median, and mode. We have discussed about mean. However, mean or average is influenced by outliers. So what is the best measure if you have outliers? If you have outliers, median is the best measure. Median is the middlemost value, and median is not influenced by your outliers. And we have mode. When you have non-numerical data, you will go with mode when it comes to measures of central tendency. And the value which repeats itself maximum times is called as mode. If you have a single mode, it is called as unimodal, right? And we have also discussed about bimodal. Let me delete this part. All right. We have also discussed about bimodal. If you have two modes, if you have more than two modes, it's called as multimodal. We will anyways look into these descriptions or implementation of this in the real world at a later point of time. Then we need to calculate the second moment business decision, which is also called as measures of dispersion. As part of this, we have three measures. Variance. Variance gets influenced by the units because the units get squared because of the very nature of the formula that is used to calculate variance. Hence, we resort to standard deviation, which is all about taking square root of variance, and you get back your original units. And we have another measure which is called as range, which is maximum value minus minimum value. And then we have third moment business decision, which is called as skewness. Skewness will help you identify the long tail strategies. Yeah, skewness can have a positive value or negative value. Positive value means your distribution is right skewed. Negative means it is left skewed. And then we have the fourth moment business decision. Let me show you that. We've already discussed about these. Yeah, skewness, kurtosis. If you have a positive kurtosis, you can say that you have a thin peak. If you have a negative kurtosis, you can say that we have a wider peak. Post which we have resorted to discussing about graphical representation such as bar plot and then histogram. Histogram will explain you about the distribution of the data. Are the data skewed? Is it right skewed, left skewed? Do you have kurtoses? Is there single mode or do you have multiple modes? All that can be analyzed using a simple histogram. You first come up with a frequency table and then come up with a histogram. All right. Now we will take this discussion further and try to understand about another very important graphical representation, which is called as box plot. And here is a box plot. Let us try to understand this. The first thing is box plot is also called as box and whisker plot. Box and whisker plot. It is not box and whiskey, friends. Understand that you all might be tempted to consume one post your statistical session. 100% of the data can be represented using your box plot. The lower extreme is nothing but the minimum value in a data set. Lower quartile is also called as first quartile or Q1. From this minimum value to the first quartile, there would be lower 25% of the data. If you're representing heights of the students, for example, lower 25 students height fall in this range. And then you have upper quartile, which is also called as third quartile or Q3, quarters, 3/4. Sorry about this. So let me choose a different color. From this third quartile until this minimum value, you would have 75% of data. What does that mean? That means that this box here would contain the middle 50% of data. And this box is called as interquartile range. Interquartile range or IQR, which is given using Q3 minus Q1. If you have 75% of data until Q3, so it would be 75% minus Q1, which has 25%. So 75 minus 25% would be 50%. And from this upper quartile till upper extreme or the maximum value, there would be upper 25% of the data. And also box plot will help you identify the outliers. In yesterday's example, or my bad, in the example that I've given while you calculated mean, I have given you this example of calculating the mean for this data set. Instantly, by looking at this, we were convinced that 700 is an outlier. However, instead of 5, if I give you 1,000,000 records, would you manually go from one record to another to identify the outliers? Would that be possible? Absolutely no. Hence, we need to resort to graphical representations such as box plots, which help you identify the outliers. All right. And since you have outliers being represented in your box plot, we have this middle line which is median. It is not mean. Yeah, because mean gets influenced by your outliers. Let us try to do the same using R. So there are too many things here. Let me erase everything. All right. So we have this MBA dataset. What if I want to draw a box plot for GMAT? As I've told you, R programming is as simple as your English language. So if you want to draw a box plot, formula is box plot of MBA $GMAT. Because whenever you want to refer to any variable within a data set, you always have to give the dataset name followed by dollar and the variable name. There we go. Here is a box plot. Let me explain this also quickly. This is your minimum value. This is your lower whisker, lower whisker. This is your Q1 of first quartile. This is your Q3 or the third quartile. This box is called as interquartile range. This line here is median. Sometimes it is represented as Q2 also. And then you have the maximum value, and this is your upper whisker. So 100% of the data can be represented, and these are the three outliers. Can we label these outliers using R code? Of course, you can do that. All right. So this is a simple box plot. Can I have outliers even towards the upper extreme? Oh yes. So let me position the mouse pointer on the console and press the up key on the keyboard, which brings me the previous function. So rather than plotting this for GMAT score, I'll do it for work experience. There you go. We have a lot of outliers here towards the upper side. Also, if I represent this box plot in the horizontal format, let me do that. Once again, the up key, I'll add an argument called horizontal is equal to true. The direction of the box plot has changed now. Now, this also will explain you about the distribution of the data. If I were to draw in that way, this is how your probability distribution would appear, and you'll have the peak exactly at the median there. And you know for a fact that this is skewed towards your positive side or the right side. This is the right skewed data. In this way, box plot will also help you identify the distribution of the data. Such small visualizations, but the wealth of information that it gives is amazing.